G'day everybody, Nick Dingle here again for another lesson. We're up to 14 and this time we're going to be talking about test data. So this is going to be a fairly simple video and it's not going to involve a huge amount of Python coding. Okay, there is going to be Python in it, but I'm not going to be coding it. We're just going to be talking about the idea of how to create what's called test data to check for errors within your programming. And these can be either runtime errors or logic errors. Syntax doesn't really come into it because test data doesn't fix that. You fixing your syntax fixes that. So what is test data? Realistically, when you put your program out in the real world or you give it to another person, the first thing they're going to do is try and break it. They put in stupid numbers. They put in words instead of numbers. They put extreme values, extremely long things. They put in SQL to see if they can inject anything into it. But there's one thing I'm not covering in this video. It's not going to be what's called unit tests. Perhaps in the future I will, but for now, no. We're just going to talk about test data. So test data is the idea that you are putting values into your program that cover what you expect them to put in, which is unexpected, and what are the extremes. So for example, imagine I've just made a really basic calculator that adds two numbers together. So imagine that I've got number 1 and number 2, and they get added together, and then we display the answer to the screen. Well, to come up with a test table, you've got 4 columns that you need to create. You've got the data column, which is what you're actually going to put into the program, the reason you included it, what you expect the program to output, and then once you perform the test, what was the actual output produced. All right, so for example, if my first set of data is 0, 0, and the reason I included that is it's the lowest value that is not negative. Well, what's the expected output? Well, it should output 0. And when I ran it, it gave me a 0, which is perfect. Now, -1 plus -1, it's a very small negative value. I'm just testing my calculator works with negatives. And I expect -2 for the answer, and it did. It gave me -2. The next one is 1 plus 9. I'm just using normal numbers, so it's a normal value. Excuse me. And I expected to do 10, and I got a 10. And now I've got an extreme value. Lots of 9s that just goes into the billions and sort of past as well. So it's an extreme value. That's why I've included it. What do you expect the output to be? But what actually happened? Well, my program crashed. It couldn't handle that bigger value. So that's just one quick example of what a test table will look like. So there's your 4 columns. And typically we just use those 4. What is the data you're going to test with? Why did you include it? What do you expect to come out? And then what was actually the value that came out? So typically when I make a test data table, I'll do the first 3 columns, leave the last one blank, and then just fill them all in at the end. Okay, so what should you include? When you are doing test data, you must include normal data. That's pretty straightforward. So you must include zeros and names and years and all that kind of stuff. You should include boundary values. So if you have an if statement or a loop that stops or is, the condition is based on a number, like value is less than 0, 0 is the boundary value because it's a boundary. Extreme is how it sounds, gigantic values, long values, huge values, that kind of stuff. Unexpected data. Give me what year you were born in, dog, okay? Be worried. And also empty data. What happens if they type in nothing? All right, so these are the types of data that you need to include in your test data tables. All right, example time. I have written this code here. It categorizes the size of eggs based on the Australian Egg Authority. I don't know if that's the right name, but I'm calling them that today. My program takes the weight of an egg, turns it to an integer, and then checks what size is it? Medium, large, extra large, jumbo, or king size. So the rules for this are, if it's a medium egg, it's between 43 and 51. Not including 51, I should say. Sorry, that should be 50. Large is 51 to 59. Then extra large is 60 to 67. Jumbo is 68 to 72. And then king size is anything 73 or above. Okay? So I've written this code to try and match this table, but I'm a poor coder. I was tired. I had too many coffees. I didn't sleep the night before. My baby kept waking me up, all that kind of stuff. So I'm like, all right, time for some test data. Now, this is a huge set of test data, but bear with me, okay? Because as you'll notice, I've tried to include as many different options as possible. So 0 is the smallest value my program should be able to handle, and it should be invalid because the smallest egg you can sell in Australia is, if I go back, 43. So if I put in 43, it's a boundary value because it is on the cusp of the medium category. So it should produce medium. 51 is the cusp of the large. 59 is the other side of the large. I think I forgot to put the other medium in, but this is big enough. 60 and 67 are both boundaries at extra large. These two are the boundaries for jumbo. And then 73 should be the king. And then 1000 is an extreme value because who has ever heard of an egg that is 1000 grams, a kilogram? Okay, a chicken egg, not going to happen. Then I chose dingo, it's invalid. And then -1, it's invalid. So what I did is I actually wrote this code in Visual Studio, and I'd recommend, if you're keen, write this code out yourself, chuck in my values and see what the actual output was. But it wasn't very good, I can tell you that. There is a bunch of problems with my code. So what was the results? Well, the 0 told me it was large. Fair enough. These two were fine. 59 was extra large, even though it should be large. 72 came out with nothing. 1000 gave me a blank. Dingo crashed my program, and -1 gave me a large as well. So obviously, there's a bunch of errors that I need to fix up in my program. Primarily, large keeps popping up when we've got something below the medium category. So that's something we need to fix. This one, I think I've just mucked up the if statement part. I'm not handling 72, and I'm not handling this crash. So how do we fix that? Well, here's my fixed code. All right. The first thing to handle the crash, I'm checking if it's a digit. If it's not a digit, I print it's invalid, and then I quit straight away because we're done here. Okay, they're idiots. They didn't give us the right thing. If they did enter a digit, I then convert it, and then we do some extra stuff. And you can see I've changed my code. Should have put these side by side. But first of all, this was equals 43. Well, it should be not equals to 43. First thing we do is check off if it's less than 43, it's invalid. And then if it's less than 51, it's medium. Less than 59, it's large. 67, extra. 72, jumbo. And then I put this if the weight is less than 210. Now, there's a little bit of method to my madness here. I actually went and did a bit of research to find out what is the biggest chicken egg ever found. And the biggest one on record so far was in 2020, where a kid found an egg that was 209 grams. So I'm saying anything bigger than 210, you probably wouldn't sell something that big, but I'm saying anything less than that would be king size, and anything over that is either complete bull plop, or you should not put that in a box with all the other eggs because it's invalid. So there we go. There is my fixed code for this one. Now I do have another quick example for you here, but this one here, I'm not testing different values as such. What we're doing now is checking what's called nested if statements. So what this code should do is very similar to the first one. It gets a number, checks if they actually typed in a number this time. I've already fixed that error. If it isn't, it says invalid and quits. Otherwise, it'll convert their number to an integer. It tells you if it's positive, tells if you're even or odd, otherwise it prints negative. So you can see I've got an if statement here and then an if statement here. I've now got nested if statements. So what I'm creating is multiple paths that I can go down, okay? I can go down the positive path and then down the even path, or I can go down the positive path and then down the odd path, or I can go down the negative path. I actually need to write test data that covers every single one of those paths in my program. So I've tried to include that here. So 0 is a boundary value, 1 is the smallest positive odd number, 2 is the smallest even, this is my extreme value, dingle is unexpected, -1 should realistically be invalid, okay? -1, okay, is a negative odd, and then -2 is a negative even. Okay, so my expecteds are all laid out here as you would probably see. Let's see what actually happened. It wasn't very good. Okay, the code I wrote in the last one actually mucked it all up. So the first thing is 0 is apparently negative. 1 is a positive even. It got half of it right, which is good. 2 is a positive odd. positive, even. You can see they're opposites. Okay, that gives us a bit of a clue to where the error was. Now this one should say it's neither positive or negative, but it said invalid, and these said invalid as well. So if I go back, I want you to have a look at this code and tell me what the problems are. I'm going to pause and you guys tell me, and then I'll show you the fixed code. Okay, so there's a bunch of problems here, and hopefully you've picked up on a few of them. And the first one is the fact that all my evens and odds were backwards. And that just attests to this little if statement here, where I'm dividing by 2 and checking if the remainder is 1. Well, if you get a remainder in a division by 2, that means it's an odd number, not an even. So I've got this backwards. So there's two ways I could fix it. I could swap the even and odd around, or I could swap that to a 0. I chose the 0 option. Okay, so that fixed. The next problem we had was if I type in a negative number, it tells me it's invalid. It tells me it's not a digit. Now this one's a little bit more complex. And the reason it is because the isDigit function doesn't handle negative symbols on the front. So how do we fix that? Well, the way I fixed it personally is I wrote a secondary if statement above it. And if the first character was a negative symbol, then what I do is I strip out all the other characters, like I did in my strings video, and check if that is a digit. Okay, if I check if the right-hand side is not a digit. I'll show you what that looks like in a second. It's a bit more complicated. And the last thing is, 0 is not negative. Well, so what I did is I changed this to an else if. It says else if number is less than 0, it's negative, and then I put else at the bottom, print neither positive nor negative. Okay, so, and this is what the code looks like. It's a little bit more complicated than before, but whatever. So this is the if statement I was talking about. If the first character is negative and the rest of the number is not a digit, so 1 colon strips out all the other letters except for the first symbol. And if it's not a digit, we print invalid and quit again. Then it goes to converting a number. You can see I've swapped that to a 0. There's my less than 0 to say it's negative. Otherwise, it's neither positive nor negative. Okay, and that's the benefit of using these test tables. The test data tables are incredibly handy at picking up tiny little errors that you may otherwise not find. So thank you very much for watching, guys and gals. I'll see you in the next one.